Let me introduce to you Mr. Eric Nieves. Eric, of course, is working with Yaskawa, Motoman, and is their technology director, at least here in the USA. And of course, he's been in the industry for a couple decades, and a lot of people in the industry know of him and of his speaking abilities. We also know of him as a visionary of sorts, and he's supported the idea of using ROS for industrial applications now for, I don't know, 3 years. So without further ado, we give you Eric. Go ahead, Eric.
Well, gentlemen, thanks for indulging my presentation in this manner. I'm in the piney forests of northern Guatemala as we speak, working on some mission work digging wells, but I didn't want to miss the opportunity to address this group because I think the ROS-Industrial effort is important. By way of caveat, I can tell you that this presentation is an update of one that I gave at Fraunhofer late last year. And I've since been asked to present it again at ROSCON later this spring. So, Uli, you're going to be tired of seeing this by the time we're done, but nonetheless, it's entitled Why Industrial Robot OEMs Should Care About ROS, but, you know, it may have better been named Why Industrial Robot OEMs Should Care About ROS and Yet Still Don't. So, you know, but that's their issue, not mine. You know, as I look at 2013, you know, 2013, we just finished our 2012 fiscal year last week. We are a March 1 fiscal year. And 2012 was a record-breaking year for us. It was a very strong year, and 2013 looks to be strong as well. And as we serve the market, you know, with this revenue and margin and everybody's fat, dumb, and happy, we did it with the characteristics of robots that you see at your left, right? So we're talking about, and I'm going to move up here because I can't quite see that well. Okay. I see it. I see it. So, you know, the customers that made us all happy this year all fall with these characteristics. So they have a large lot size, you know, repeatable tasks with very few program changes. The robot programs were generated by someone with some amount of training anyway. The robots were separated from us. They were on the other side of the cage, and by and large, the robots were parked. In some cases, we got fancy and put them on 7-axis servo tracks, and even in some cases, we put them on, you know, overhead radial gantries because we're cool like that. But as a rule, you know, 2013 was a very strong year in these applications because 2013 was a strong year for automotive, okay? But I have a business to run, and as I look forward to beyond 2013 to 2020, you know, I know that I've got to do something different. So you want to get the next slide for me? Yeah, so 2013, I was able to service the market with this robot. You know, effectively your 6-axis machine, and we sold them in quantities for all sorts of applications, right? But as I look to 2020, and we want to grow the market, right? I need to do that because if you'll notice in 2013, I have robots above in red. And that's because even though it was a good year for us, it was a good year for all of us in the robot industry. This is a mature market. So, you know, the growth rates aren't what they're going, you know, what we wish they were. As good as they are, we know that it's a competitive landscape. So as I look to 2020, and you want to back up a slide here a minute? Thank you. So I want to move towards these characteristics for applications, right? I want an ROI that's a smaller lot size, that can be afforded with a smaller lot size. I want it to be that one-off tasks are standard. Why do I say that? What is it that I want? It's not about what I want. It's that as I look at the business and where we need to go for growth, it was actually a pretty straightforward exercise. All we did at Yaskawa, all we did was go back through and look at all the RFQs that we no bid. We looked at all the jobs we turned down over the last 4 years and said, why is it that we didn't take this job? Or that anybody took this job? Well, most of the time it's because, they can't afford a robot. Look, they don't have near enough volume to warrant this automation. Or they have so many different part numbers, they're going to spend more time programming than running, and it's just not efficient. Or, to this third point, they're just an immature house. They don't have any, expertise. They're not in a position to add robot talent out here in rural Kentucky. It's not going to happen. It's just not going to go well. So we no bid it. And then we have the collaborative piece, right? The application is so complex that you would have to have such a crazy tool to do it all in an automated fashion. You just wouldn't do it, right? You'd have to have a person go in and out with the robot so often. And we just don't want to get into that. That's collaborative work. But that's all the business we turn down. So for our growth, as we're looking to run this business, I have to look at production partners for 2020. And so when I go back to these people that asked me, is there anything I could do for them? I showed them this. And they said, well, that's cool, but, it's not any easier to program. It doesn't go to where the work is. Tell me what the benefit is. I don't want this robot. I want, next slide, that one. And I can't deliver. I can't. I understand the requirements. I understand that, you want to be able to have the robot service the work wherever the work happens to be in your plant. I understand that you want it to be very easy to program, that it will, if it could, it would program itself. I get it. I just don't have the tools to deliver it. So what am I going to do? Right? Well, after we went through this exercise and saw all this business of people that had purchase orders they would be willing to give if somebody could service their needs, that's when I went on my fishing expedition. Next slide. So this graphic represents 2 years of my life. I spent, a great deal of time surveying the robotics development power in the Americas. I went to all the major research institutes, went to the universities, MIT, CMU, Georgia Tech, Stanford, University of Texas, Waterloo, all of them. Just trying to understand where were these technologies going to come from, because I wasn't going to be able to deliver them. So we could spend a lot of time on this slide because the colors actually mean something, but we won't. Suffice it to say that as I took and moved east to west, all right, there was this recurring theme. Nearly everywhere I went, people were developing in ROS. Next slide. So Mama didn't raise no fool. I figured if these are the institutions that are going to be developing the next generation of technologies for automation and robotics, I ought to make it easy for them to adapt those technologies to my equipment. So we partnered with Swery and generated, our first rudimentary interface to one of our robot controllers. And we based it on this 7DOF machine just because, people like it, it's researchy. And then we've since, ported it over to 6 Degree of Freedom arms as well, right? The idea was to have a bridge between the ROS tools and our standard robot controller. Next. Okay, so here's another example of material handling. Same robot, same programming interface, same language, but now I have to do everything, or largely, coordinated between these two arms. Okay? So I'll have some independent motions where I'll drop them. But then here, for instance, I'm having to work in a collaborative fashion, arm to arm. There's a lot of motion planning having to happen here. Picking components, etc. We were able to create this, robotic kitting demo for one of our users with our informed language and our teach pendant approach. We did it, but man, it was a pain in the neck. Okay? It was cumbersome to do this kind of work with a standard programming interface, especially like this. It looks slick and it worked well, but it belies the effort required to generate this program. This was not easy to do. And mind you, it was blind, okay? We staged all these parts. If I would have had to add in a whole layer for machine vision with all of those components as well, this demo wouldn't have ever happened, okay? It's clear to me that, and maybe this is why Yaskawa is on the ROS bandwagon before, some of my colleagues, because, these exercises demonstrated to me the need for new programming, and ROS provided them for me, improving the ease of use. So it allows us, it has tools for whole body control where I can keep one hand still, maintain the pose, and still drive the other arm, including the waist axis, to do coordinated motion elsewhere. Whole body control is difficult. The collision avoidance tools that ROS offers. These were some of the things that drew us to the ROS environment. Next. So you saw this video, I'm sure, in Sean's talk, and many of you saw this demo in Chicago. But here is an example of a dual arm application, if you will, right? That included vision, that was doing, this sort of material handling, but was easy to program. Now, I don't claim here that we would have been able to do the same kitting operation between hand and hand, between a universal arm and ours, like I needed to do in the previous demo. But nonetheless, this is a path forward for me, right? ROS provides me tools to improve the ease of use. Okay? Okay. So, OEM criticisms about ROS. This is what I hear when I talk about ROS with my colleagues. I already know how to do IK. I don't need ROS. I already have the expertise, right? It's not invented here syndrome. Well, what this really belies, what this really demonstrates next, is a lack of understanding of what ROS is offering. When I talk to some of my, other technology people at my competitors, what I hear is, all about kinematics. We already know how to do our kinematics. Yes, I get that. We're never going to use ROS for IK. We can do that. It's all of the things outside of IK that ROS is going to help us with. So when they say they already know how to do it, either they don't understand what they're saying, or I don't know what they're talking about. Next. ROS adds little value to process robots. This is in fact true. Okay? When we talk about process robots, go ahead and click, Paul. We're talking about spot and arc welding and degree, right? And these applications make up the volume of industrial robot sales. And to a large extent, ROS has no tools for making a spot weld any better, or making an arc weld for John Deere any more robust or stronger. So, it adds little value to that. Now, you could argue in paint, given some of Swery's work, that ROS does have tools that support the application. but they are independent, those tools, of the actual process of painting, right? So ROS adds little value to process robots. I get that criticism. I just would point out to them that paint, spot, arc, these processes are largely tied in volumes that we've been enjoying to the automotive market and the tier suppliers. And if you're happy with living there, then I have nothing to say to you. Next. OEMs are not startups. We don't need open software. Yeah, excuse me. I get that too. This is a true statement. But its value of ROS, excuse me. The value of ROS is not that it's open source. It's in the tools it provides. Next, please. So, if you are an industrial robot house,
Eric, you gotta spin around for a second and take a little bit of a gander at your audience.
okay, hang on. Okay, guys, give me just a minute to get a drink here. I'm dying over here. Okay. All right, so what are we talking about? We're saying that some of these tools that are, OEMs worry about it being open source and they don't need it. I'm not saying you need it because it's free. I'm saying you need it because you don't have the tools it provides. Next. Okay, this is the big one. Open source software. It's unreliable. It's an unacceptable risk. We're a mature market. We've got to make parts. I have a 60,000 hour mean time between failure I need to uphold, and I am not going to rely on some college kid's piece of code. Okay. That's a true statement. And the bar is very high in industrial robotics. But the bar is likewise high in IT security, in lots of other places where the open source model has proven itself, right? Go ahead. So it's like we believe in the industrial space that we are exempt somehow from the open source community just because we're held to tolerances and to requirements. I think that's rubbish. I do think that we have to be careful and we have to be diligent in how we apply them, but I will not discount technologies offhand simply because they are open source. Next. There's little that ROS offers that impacts the robots we sell today. That's true. In fact, largely all 5 of these are true. It's just, it's true and so what? Right? And what they're saying when they say it doesn't impact the robots we sell today, that's really the basis for their rejection of the rest of this. Okay? And to those that, go ahead, if they're fine chasing today's applications tomorrow too, then I have nothing to offer you. This isn't.
He's drinking water. No, it's dead.
Okay, no, we're here.
Okay.
I hear you, but
It's
I'm
not to
not
rescue
seeing
you.
anything.
You're back.
Okay. All right. Next.
Click.
Okay, so yeah, here's the problem with today's market. This is a graph of the SAR, the seasonally adjusted annual rate for automotive sales in North America. And you see, as long as we're over, 12 million units a year, the robot industry will be fine. If it's over 14 million units, we are cooking with gas, okay? But look what happens to, when 2007 happens, 2008, 2009, the robot industry sends everybody home, okay? We need to get off of our, gross dependence on the automotive industry. We can do everything automotive requires in the body shop today using our standard technology, but we can't do anything else. Next. Go ahead. Okay, so what's the business case? We got to recognize that it's a business risk to be this tied to automotive. And some of my colleagues, when they see this, they say, you know what, Eric, you're living in the 2000s, buddy. The real action is in material handling. That's where we're seeing the growth. That's where we're making our money, is in material handling. And I believe that. And insofar as the material handling application looks like an industrial robot application in an automotive shop, meaning it's repeatable, it's program once, run, for months at a time. All of those things that we talked about for the 2013, as long as your material handling application looks like that, you'll be okay. But that's not enough, right? So it's a business risk. It's cyclical. We can't depend on a SAR above 14 million units, year on year. So, what's my mitigation to this real risk?
Waiting for the ghost of Eric Nieves. There he is.
Okay. So what I need to do is to mitigate this risk is to get away from such a heavy dependence on automotive. So that means I have to have new functionality. If I'm going to serve all of those users that came to me that I had to no bid, right? I need new functions that I didn't have when I turned them down. Where am I going to get that? Go ahead. Okay. If you have, these new functions that you require, you've got to go develop them. As OEMs, we're not in a position to do that. Our development resources are consumed. We are on a treadmill, okay? Meaning, what is it that we do all day in the development groups at Motoman, Fanuc, I don't care who you're at. Next. What do? We maintain the standards, right? They could be construction standards like reduction of hazardous substances. It could be ISO standards for safety. It could be the next, CSA for electrical specs. Any of these standards things, okay? The other is iterating. We iterate a lot for our users. They'll say, hey, look, we love your robot. Could you give us another 100 millimeters of reach, and could you do, something on the axis 1, give me another 15 degrees range there, and could you make it a little faster while you're at it, right? And if you do that, we'll buy 60 of them. Okay, we'll do it, right? So we iterate a lot on our standard technology. That works great. It also means, you're about 5% faster than your competitor for about 6 months, and then you've lost your advantage, right? It's just the nature of this beast. So there's very little market differentiation in this iterative, sort of approach. Next. right? Oh, what is that? Oh, managing obsolescence, right? I mean, we have guys, this is what they do. We find out that the outfit that's making the tachometers for the fans that go on our servo packs is changing spec, and now we got to change connect. I mean, there's all of this sort of maintenance of your own product. It's really very little development in the case of something new. Now, I do not mean to poo-poo any of this stuff. This is important. And it's important the same way that a treadmill is important. This is a point I brought up in Stuttgart is, if I spend 3 miles a day on the treadmill, my doctor's gonna be happy, I'm gonna feel good, there's lots of benefits to being on the treadmill, but I'm kidding myself if I thought I went anywhere, right? That's where we're at in the robot industry when it comes to development. We spend all our time servicing the customers we have. That's what development does, right? Next. So what's the value of ROS to us? First off, it has none. ROS itself is not the value. The applications it enables are where the action is. That's my only interest, is the applications ROS enables. And I should be clear, when I say ROS, ROS has come to mean a couple of different things. One of them is, the very, known set of functions that are within robot open source. But ROS is a little bigger than that now. ROS has sort of become a brand. And under the umbrella of that brand are all of these sorts of technologies that grew out of the same effort. So whether we're talking about OpenCV or PCL or ROS or MoveIt, all of this is what I talk about when I say, ROS's value. All the interesting peripherals and the algorithms will be developed on ROS first, long before they're done for me or any of my friends. Okay? This is just the reality that I learned as I visited all of these institutions. I could put a Motoman robot at every robotics program in the country. I still wouldn't use our language and shouldn't. ROS is going to be what they do. Okay? OEMs that have a robust interface to ROS, to me, it's all about first mover advantage, right? It's time to market for these new capabilities. And all I'm looking for is 18 months. Give me 18 months lead out front so that I can get entrenched in a couple of applications, and that's all I can ask for an open source development. Next. It offers a development community that is not in the mud of maintaining my existing business. Okay? I want ROS to happen independent of me. You put it inside my building, and I know what's going to happen. Okay? It's going to get sucked. I need to. So, ROS developers are the next crop of robot talent. That's true. When I look for the next programmers that we're going to hire, developers, etc., it's the guys that are doing ROS today. Those are the ones that I'm looking for. They have the right mentality. They're, robot savvy. They like this area. Of course, that's what I'm going to look for. Okay? All right? And, ROS-Industrial is an important work. It is true. We do need to have a hard and stable version of ROS from which we can proceed. So, Yaskawa is thrown our hat in with the ROS-Industrial Consortium, and we're glad that you have too. And, go tell your, colleagues and friends that they should do likewise, because we're all really going to benefit in the end. So ROS's value, to us as robot manufacturers, some see it. I do. I believe in it. Yaskawa believes in it. And, to the victor go the spoils, and, do us all a favor and make us look good, Sean. So, okay? And I think that's the last of it. Is that right? Okay. I'm happy to field any questions, or, we could, if you have any, and if not, I'll go back to poking a hole in the ground.